Alright, so the title of this talk is The Power of Interpolation, and we're gonna talk about what that is and how that specifically relates to React Native. So before we start, just a couple of words about me. I work at CallStack, which is a company that that has this mission to help developers like you and companies launch their products for everyone at the same time for every platform. So we basically do universal applications all the time, and it just happens that we are using React Native right now for the past 2 years because we believe that it's the sort of the best framework out there for this particular reason. And since we are very excited about open source, we started doing a lot with React Native, and that's how we sort of became on the core team of React Native. So if you are following React Native, I'm these days mainly doing releases and making sure that the CI is green and stuff like this. As a matter of fact, the latest release is delayed because of CI issues, so sorry for that if you've been waiting for it. So if you're interested in hearing more about React Native and the releases and problems, you can follow me on Twitter. I don't mind. I would be happy with every new follower. All right, so let's dive deep to our talk. Before we start, let's get a better understanding of our background. So how many of you are working right now on any sort of mobile experience, either a native platform, JS, Wrapper, Cordova, something like this? All right, quite a few people. And how many of you are coming from a web development background? Okay, and those who didn't raise the hand, what is your original technology, let's say? Okay, so you just started with React Native, I'm going to ask you. Which means JS as well. So the truth is that most of the developers within the React Native community, they are coming from web development background. And React is the most popular framework amongst them. And in fact, which is sort of my personal belief, React is what makes React Native so exciting for people, and is what makes you to actually go ahead and try it. Despite all its issues and bugs that it has. And in fact, without React, all its benefits start to sort of wear down, and like, if you would ask me what's the difference between React Native and Flutter, if it wasn't for React Native, if it wasn't for React, that would take me quite a lot of time to actually explain the benefits, or for example, why to go with React Native over Flutter, which is a similar framework from the Google open source. And with the web sort of experience that we have, we carry something that I named a web debt, which is a set of sort of best practices and tools that we just sort of learn and get used to over the course of our career. Probably most of you started writing static web apps, then went over from tables to divs, added some jQuery, then Angular, and ended up with React. And that's our experience and what defines sort of our proficiency in the industry, right? So why it's actually a debt if it's a good thing? So the reason is web and mobile platforms are fundamentally different. They have different expectations and they obviously work in a different way. And the former one uses mouse obviously as a pointer device, and is available right away for you and has a lot of constraints, like you have to paint real quick for the user in order to keep his attention. You have to sort of optimize the bundle size for a variety of use cases. And in terms of animations, like people just don't like bloated web apps. So if you do something with scroll, there's like at least one tweet per day saying, oh, these guys are hijacking scroll again, which is crazy. And one thing is that our users just expect our apps to work this way, and the other is that like creating animations on web and all that sort of experience is just harder than on mobile. And unless you're working on a game or a sort of highly interactive project, most of the animations, sort of transitions that you will be working on, focus on transitioning between two states, right? If you hover an element, it has two states, hover and not. When you click here, you have the start and the end, and the carousel can switch, but it's again one page and the other. There is nothing in between. You can't actually pause this because you clicked it. That was sort of one-way interaction. And the latter, unlike web, is different, right? Because we have our fingers. That's what, I'm not sure if you have been watching or YouTubing Steve Jobs announcing the first iPhone. He was like, we're gonna use stylus, and then he was like, no, we're gonna use our fingers. That's because, like, on mobile, we use gestures and our fingers to actually control what happens on screen. And that's sort of experience that most apps are delivering these days, right? As you can see, the app is sort of highly interactive. You can sort of play around with animations all the time. You can pause them, you can revert them, you can do pretty much whatever you want with them. They're just kind of bound to your gesture. They are following your finger as you interact with the screen, right? So it would take us quite a while to discuss all the differences and why they happen. So let's maybe, think for a moment, and I'm wondering if you can tell me, like, one reason why these two are different. Like, why these differences did happen. Why mobile is so juicy and animated, and web is very rough and has, like, these mouse interactions.
Legacy.
Okay, that's a valid point.
Hardware.
All right. I think that's enough. So that's better than non-answers, so that's good. So that brings us to the APIs, which is a combination of the things that you mentioned. The reason is that it's just sort of easier to create a hardware-accelerated, fast animation on mobile. And if you think of, for example, iOS, where you have a lot of APIs that are hardware-accelerated and very easy to work with, that sort of defines the reason for that. And React Native has this animated module that kind of brings these iOS concepts to React Native, and then through React Native Web, also to web. And that's what kind of makes this sort of interactions easier, and we'll see why in a second. But unlike mobile, web didn't start with the best APIs first. We've been doing Flash, but that was before I even learned about laptops, so don't quote me on that. And then, before CSS animations came up, we've been most likely sort of doing this. If you are like me and you started when this was like the thing, you've been doing probably a lot of that code, listening to click events, like toggle was like the thing. Even with CSS animations, I remember that was a very popular solution. And for many years, I've been like this child on this GIF, working on the problem of animation through the eyes of imperative developer. It's been sort of, working throughout all the animations that I've been building, just to fail at the end. And all in all that was the approach that I sort of learned when I was writing jQuery. It was like so idiomatic to me, so natural that I couldn't even imagine that other ways of animating things on screen ever existed. And that's what the web that is, that we carry over and over. All these assumptions that we sort of gain from the first platform that we ever interacted with. So a good example would be, for example, object-oriented developer who is asked to write functional programming code. He would be like kind of lost for the first week trying to grasp all these concepts. Probably the other way, but still it would be just a different world where like things are different. So let's take a look how to overcome these limitations, especially in the context of animation. And the reason we are talking about these limitations is that when we, as web developers, join React Native in order to write a lot of experiences, the problem is that we use these assumptions to create screens that are not exactly a mobile app. I mean, it's a native mobile app, but it's different from what other really native apps are, right? Because native platforms have their own design guidelines, like material design or iOS human design, that has some sort of, constraints as far as how to animate stuff on screen, how to place elements, how to lay out stuff. So the thing is that before we actually start doing sort of experience on mobile, we have to first understand the platform and forget about what we assume should be the default, because the defaults in case of mobile are completely different. And there is no better explanation than code, so I'll be using a tool that is called Stack for React Native previews. And if you haven't heard of it, it's a CodePen-like platform where you can just write your code in a browser, and on the right side you will be able to run React Native Simulator. That is using Expo and is running in the cloud. And all the examples that I'll be showing you, I've kind of pre-recorded and pre-uploaded there, so that once I share the slides and links with you, you'll be able to just kind of glance what's there and sort of analyze the code yourself. And originally, I had this sort of live coding part where I open my browser and I click this tab to play, but given all the issues we always have with live coding, I decided to pre-record this. When I was in ReactConf, one of the speakers that had this issue, he said that he didn't pray to demo gods, and that's probably why it's failing. And I didn't do it, so I better just use the videos. So what we'll be building to show you, the animation stuff. So let's take a look. This is I don't know, like the first thing that popped up when I googled React Native collapsible, native mobile app, something like this. So when I googled that, this popped up, which is a really good example because like these days, especially on Android, when you scroll, these tabs just hide, the header changes, a lot of stuff happens. I think even on Twitter, when you scroll on the profile page, something happens to the profile avatar. So how do we go about implementing this? So the first thing that comes to my mind, and hopefully yours as well, is to listen to scroll event, capture the position, and tell a header to change its height, right? That way, that's what we probably would do back in web these days. So I'll just leave this code for reference. That's how I define 10 random photos to display on the app. I'm taking them from Unsplash, which is a nice service for providing license-free photos. So the next thing I'm going to do is I'm just going to create this basic React component that is going to have the header heading state that I'll be using for the purpose of animating the header. And then the next thing I'm going to do is I'm going to create this sort of component that's going to have basically the view that has this height and background color. This is going to be our header. They're going to have the blue background. It's going to be at the top. And below it, there's going to be the scroll view that's going to be rendering the elements. And it's going to be faking the real case scenario list view that can have like hundreds of elements. And finally, scroll view has this on scroll event, so we're going to just listen to it and get the scroll position in order to manipulate the height of the header, subtract it from 100, which is just a random number I used for the sake of this demo. And as you can see, it sort of animates kind of well, if that's what you want, right? So it's not that bad. But there is one thing missing in this example. Can anyone tell me what? Yes, that's right. However, if you take a look, you'll see that it basically disappears when you scroll too much, right? So that's exactly what you said. And so the thing is, we didn't implement all the states and all the possible scenarios of the scroll position and the outputting value. And the problem is that, if we scroll down too much, as we can see, the header disappears completely, which is probably because we are subtracting from 100, so we probably would need to go ahead and do an if statement to check if the header height is less than 0. So that's what we can do. As in this example, we can just add this ternary expression to check for the header height, and if it's less than 20, just use 20, otherwise use the real header height. And then the example sort of looks okay, and no longer has this problem. Obviously, I was that was kind of out of scope for this demo to render all these tabs. So I just decided to make the header, a clear view of the background. So the question is, are we done here, since this is working? So the answer is yes and no. So the imperative approach that we did here kind of works, and as you can see, once we add some if statements, it's sort of gonna get us there. But don't forget that this approach is just like this child going downstairs. You know, there is always that step in the future where this will fail. And to give you a good example in terms of the boundaries, I've been working on a project that I'll show you at the end as a perfect example of the interpolation. And I started with the imperative approach, and I've been adding those if statements. They were just adding up as I was adding new sort of scenarios. And a few months later, I came back to the code base, just sort of refactor it. And it took me like more than a day to understand what I really meant by these if statements. Like, this was easy because the header head is sort of easy to understand, but if you have a complex animation and you forget to document it because sometimes we're in a hurry, then we have a problem. So that's one thing. And the second thing, obviously, is the performance. So just like with React, when you sort of do declarative rendering, you leave all the optimizations to the framework, right? So it can compare the trees, it can do its diffing stuff, it can sort of asynchronously, probably in the future, render things, just to make sure they are getting laid out on screen in a most performant way as possible. And same things with animation. Like in this case, we have imperative approach that basically will be sort of changing the header height every time you scroll. So these things will be adding up, and it's gonna be most likely more than 100 of calls as you scroll, because these events get fired really quick. So the problem is that you will be slowing down your app, and you will not be able to do the animation on the native side. Because how we can optimize the animation if it's imperative, right? Like, we are rendering the animation rather than defining the animation. But fortunately, there is this concept of interpolation in React Native that makes that sort of experience very easy. Before we go deeper, how many of you have ever played with CSS3 keyframes? All right, so everyone wins because those who did play, this will be probably the same, so it will be very easy for you to grasp. Those who didn't, once you learn this, you can also do the keyframes once you get the syntax. So what is that interpolation in the context of React Native? So instead of telling our view to sort of, instead of telling our view when to update, like as I scroll, go and change the header height, I'm gonna basically describe the relation of how my header should look like when any number, like a scroll value, changes. I know that might be sort of hard to explain, we'll see in code, but the most important thing here is the static nature. Rather than having async code that modifies my layout when event happens, I can describe everything without actually running my app. I can describe, like, for this height I want this, and for the other I want this. And the static nature allows me to debug this without actually getting the animation to start. So think of it as a curve of a function, which is really important because, as we'll see, these animations can get very complicated, and handling some edge cases will never be easy if you don't do it statically. So we'll start with sort of changing our example to see the difference at a glance. So instead of having the header height in a state, we'll start with the scroll value. So that's the first difference. Rather than storing the header height that should render, we'll be storing the value that will be telling our views what to do. This animated value is just a wraparound number that has the .interpolate method that we'll be using. So you don't have to be thinking what that really is, just assume it's a pure number. And then, rather than having this onScroll event, I'm gonna do this animate.event, which will sort of create a function that will map the Y property to my state. I know this syntax looks strange. I sometimes have troubles writing that off the top of my head. I have to go to docs, so don't be afraid if that looks very weird for you. It is weird. But the point is that you can sort of, I'm not sure if you are getting this fun thing here that I'm not defining a function here. I'm actually using animated.event, which is a higher order function. And how this gets mapped is just out of my control. It can be done on native side, can be done on JS side, I don't care. The framework's gonna optimize it based on how's the performance are up. And finally, we'll do the interpolation, meaning that we will calculate the header height of the value that we have. So as in this example, I'm specifying that I'm interested in scroll value 0 and the 300, which are the boundaries that I'm interested in. And for the 0, I want my header height to be 200, whereas for the 300 of scroll, meaning that I scroll down, I want the header height to be 90. The extrapolate property is just to make sure that the interpolation is not sort of assuming what's next. Without it, if you scroll down, we'll get the glitch that we had on the first example, because interpolation will be like, okay, if you want 90 points for a 300 scroll, and we got 600 scroll, we will just kind of calculate the proportion, and we'll get the value. And that's the example. With just one line of code, we were able to sort of get rid of at least one if statement, and in production code, there can be even more. And that's the real beauty of React Native, that it makes it easy to write these sort of complex interactions, because it uses that declarative approach even in places that I would think it's impossible, because like animations, I remember when I first heard of animated module, I kind of had troubles understanding the concept and switching my mind from telling to describing, which was quite interesting to explore. However, the talk was meant to explain the power of interpolation, right? Not the interpolation itself. And that said, let's think about how do we start our animations. So in most cases, animations are started as a response to gesture, whether it's a mouse or a finger moving the screen. That's how we start the animation, right? That's the input source. And in the case of today, we have bound the scroll event to scroll value in order to actually change the layout of our screen as we scroll. So in other words, gestures and scroll events are just yet another inputs that can be used as an animated value, right? The truth is that pretty much anything that changes over time can be an input. Not just a gesture, not just a scroll value, but pretty much anything. And quite recently we had this case that we had to build a media player app for singers. And they are always hard to build because there is a lot of moving things on screen. You have to not only make sure that your UI is perfectly in sync, but the progress bar is in sync. And sometimes you can even toggle the progress bar and seek to a timed song, and everything stays in sync. Like if you check Spotify, it's like a super well thought layout and app. And there are a lot of very critical concepts that you have to do properly and make sure that they just don't get out of sync. And this one is hard in particular because it's for singers, and as you can see, it has a music score notation. And the thing is that once I hit play, it will basically start scrolling horizontally, which is sort of easy, right? There is the 0 and end of the song, we could do it. Just like a scroll value in the first example, but different direction, right? The problem here is that the speed of the scroll changes, as you see, because right, song can be faster, can be slower one time. So this is not exactly a linear scroll. It's actually, a different curve depending on where we are in the song. And if you've been into music, you probably know that this is like a different note than this. It's like faster, slower. So that changes quite a lot. And the client came to us because he already had a native app on both platforms, but it was hard to maintain and had a lot of glitches. Problem was, the previous company, do you know what was the fundamental thing they did wrong? So they made the code imperative. When we got the source code, because I was kind of curious to hear, what's wrong. Because the client was like, we hired the best native company in Europe, and they didn't do it. So I was like, I gotta make sure I'm not gonna put my company on fire while accepting this. So I checked the source code, and the first thing that I've seen was they were manually changing the SVG, because that SVG is a web view. They were manually sort of updating the translate X or something like this to change it. And the thing is that, as I said, the tempo changes, and that was just adding up a lot of traffic on the bridge. So we started with the player component, which is responsible for playing music. And I've been doing, like, if you are interested in hearing more on how to implement a music player in React Native by going with components rather than APIs, I made this talk on React Next in Tel Aviv 2 years ago on quite similar concept. Anyway, when I was working with the player, I found a lot of similarities with the scroll view, right? Because what's the problem with the player, especially in context of React Native? It's this on progress event here, right? Because like if we have a song that can have a progress either 0 for the start and some numeric value for the end, that progress has to be called how often? Actually every second, because actually at least every second, because that's how we play the song, right? Seconds change every second. But if I want to animate my layout, by the time of the song, I have to post this 60 times per second, right? Because in order to get 60 frames per second, I have to update this value 60 times per second, because if I do it once per second, there will be just one update, which will make this animation like this. So, what I had to figure out is how to do it, and how to avoid the overhead of the bridge. Because how many of you have like played with React Native and heard of the bridge? All right. So those who haven't, the thing with bridge is that in order for React Native to actually communicate between React and Native, it is using that bridge concept, which is arbitrary native code that is listening for React commands, JS commands, and is going to native and executing some commands on the native side. It doesn't really matter how it does it. The thing is that it's a sort of a single point of, like it's a bidirectional flow, but it's just one bridge, and it's not multi-threaded. So everything that you do can be multi-threaded on JS side or on native side, but it will always have to stack in this traffic, so it's like having highways on both directions of the city and a small road in a city center. And you have to think how to overcome this, like how to write your code that can bypass this traffic, that can still be fast. I don't know, maybe like leave the car and walk around this traffic issue, something like this. So I was thinking how to do it. And that's when I thought of, you know, the animated value, and that it can be interpolated because duration of a song is actually a number that changes as I play, right? And that was the light bulb moment for me, because that's when I discovered that I can define the relation of my UI with the number that is actually time and song. So the first time I thought of that changing tempo and writing that complex transition, I was like, this is super hard to maintain. But when I made this interpolation, it actually became super easy, because all I had to do was just to define how I'm going to move the left property of this view given times in song. And the cool thing is that animated view can be done natively, meaning that once I define interpolation, once you define, like, imagine you define an array. For 0 milliseconds, I want the left position to be 0. For 50 milliseconds of the song, I want it to be 1, etc., ending up with the end of the song. You define this JSON, you pass it on the native thread, and the native thread is not going to notify JavaScript of the on progress, because it already received what it wanted, right? It has the definition of the animation, and it will just do the animation natively without going to JS thread. So it's like, to overcome the traffic in a city center, you're just going to send a courier to one of the sides of the city, and they're going to handle the thing on their own, which is great, because as you will see on the demo, this is like 60 frames per second on Android, which is like not a common thing to present. So here's how it works. You hit play, there is this red bar scrolling. As you can see, notes are highlighted, and the tempo sort of changes as you sing. You can stop it. You can seek forward by obviously scrolling it. You can seek backward. And you can start, and I actually don't have to care whether notes will go out of sync. They always be synced because that's statically defined. Which allows me to do pretty much whatever I want to do with this, including doing vertical mode, or for example, you're playing the song and the phone is calling, right? Like your friend is calling, you would like to stop this. I just have to stop the playback. I don't have to think about any other edge cases like whether the node is highlighted, what happens when I resume. I don't care, like I just stop it and the UI will automatically update. And that's the real beauty of interpolation. It makes things easy that would be kind of impossible to do otherwise or to maintain. Yet it's still very easy to work with, very easy to understand, and very easy to debug. And media playback, scrolling, these are just examples of what you can interpolate. As you can see, it doesn't have to be a gesture. It can be time in song that is coming out of the native media player, for example. So those who raise your hand at the beginning, I encourage you to reflect on your existing mobile app and see if this concept of interpolation could somehow help you create better animations. Thank you very much. I'm not sure if we have time for questions, but I know there will be Q&A after. So if you would like to know more about this topic or pretty much anything on React Native, I'm happy to talk a bit about it. Also, I can show you real code examples on my laptop. So yeah, thank you again very much, and yeah,
So
enjoy the
we
next.
have time for questions because Adrian needs to set up his laptop
so,
first. So if you want, if you have any questions about the talk, later on we will have a Q&A session about React Native in general. But about the talk, if you have any questions, just raise your hand and I'll come over and give you the mic.
So I did not understand when you say there are different ways for mobile and for desktop. That must be true in the past, but nowadays it's one source of fitting for everything.
Yes, that's true that there is one source, but the thing is that it's good and it's bad on the other hand, because if we think of I'm not sure if I understand your question, but if we, for example, think of what happened when people started writing web apps with Ionic, for example.
I'm not talking about Ionic, I'm talking about PWA.
Okay, so that's also one of the things that is worth discussing. Regardless of the progressive web apps performance and whether they are useful or not, the thing that is, and actually these concepts apply to web apps, progressive web apps as well. The thing is that if you are writing a progressive web app, you should think of writing a mobile app, meaning that think of how to structure your layout in order to be kind of mobile first rather than being responsive web app and stuff like that. Because that's if you bring the web sort of attitude to mobile, users will see the difference that, for example, this button on this side menu is just a different concept or it just kind of slides differently and stuff like that. And that also is sort of true for animations where you have to sort of make them more of them rather than just state transition between A and B. So that was the point that I wanted to sort of stress out, that at least from my point of view, it makes it's extremely important to, regardless of the technology you use, to sort of design for the platform and don't get too deep into sort of reusing 100% of your layout, because that is beneficial, but can get you to a point where it's sort of not good for any of these platforms, right? So, yeah.
We do it afterwards.
Okay, not a problem at
Go
all.
longer and longer.
Okay, happy to discuss it.
More questions? Yeah.
Thanks for the talk. The obvious question, what are the limitations of the animated value? Because I know there are a couple.
Oh, really?
Yeah.
So I'll be happy to hear more about them. I don't know, maybe it's because I've been creating particular animations. To be honest, the biggest problem that I had with animated value is not the fact that it's limiting, but I just discovered that some sort of animations are just better made for other APIs rather than animated value. The player or things that animate over time of something like of a value are a perfect candidate for this API. However, when you have a shared element transition or animate between two layouts, that's when I, for example, had more experience running layout animations or just manipulating the layer itself. But as I said, I'll be happy to hear a bit more about your animations, because you know, maybe we'll discover some improvements here and there to kind of make it easier.
There was another question.
I have one question. When you look at the list view, and a lot of people have been writing ordering, like drag and drop in the list view, for example, and then React Native came out with the flat list.
Yes.
And then all that support is missing again, these animations. Is it the idea that React Native is going to support more and more UI elements with these animations in it, like the header you showed there? Or is it left to third-party engineers to make NPMs and support, for example, drag and drop in the flat list?
So in case of the flat list, that's probably purely a decision of the engineers on the team that had some, you know, ideas. There is nothing like a general repository guideline that says, okay, you should implement this that way or the other. In most cases, the idea is to make as little code as possible, but leave as many escape hatches as possible. So the answer would be try not doing that, but make it customizable. So the React navigation, for example, I know it's bad, but it has a perfect foundation for animations because it has built-in animated animations, but it allows you to sort of modify it if you want, and it has some hatches in a few places that you can use. So that would be the idea, probably. If there is something listing in the flat list, I'll probably reach out to Brian, who made it, and see like and Spencer, and see what's the idea and what's the sort of motivation they have.
Next question. So if there aren't any more questions, we will hand it over to Edwin.
All right, you want this microphone?